Okay, so so obviously you don't know me, right? You only know me because of what you saw in Behind the Curve, correct?
Yeah.
Okay, and from what I said in Behind the Curve, um, you took that and interpreted as, what I was saying is that the Earth was spinning, right?
Yeah, you said 15 per 1 hour and 15-degree drift.
That is correct. That's exactly what I said. And you know what? I wasn't lying. That's exactly what we registered. The problem is what the producer interpreted that and actually cut the editing to make it look like. So would it surprise you if I told you that, I completely agree with everything you just said. I absolutely did say that, but unfortunately, um, because of the way the producer twisted that around, I was not saying 15 degrees per hour of Earth rotation. Now, do you want to know how I know that?
Because your gyroscope, your like $40,000. What was like? How much was it?
Well, first of all, it wasn't my gyroscope, and second of all, I didn't do the initial test, but
Oh,
I got credited with that, so I'm just gonna wear it. Okay. But we took that gyroscope, and like I said, when we first plugged it in, we got a 15 degree per hour rotation. And actually, it wasn't specifically 15 degrees per hour. It would be an interpolated value, taking the sine of the latitude times 15 degrees per hour, which would kind of equate out to that. Okay, so let's make that perfectly clear for one thing. But secondly, um, when I was in the movie, yeah, at that time when I stated that, I had no idea. I was just as surprised as anybody else. And yeah, I was very reluctant to accept it because I was trying to interpret, exactly what we were seeing. And I came to find out later on, and by the way, I did tell the movie producer this, exactly what we were seeing had actually been measured and discovered over 100 years before in what was called the Michelson-Gale experiment, right? The rotation of the luminiferous ether. So at that point, then what we were faced with is we had the challenge of, well, how do we prove that it is not Earth rotation and was in fact the luminiferous ether? Now, some people, and I'll even say even in this panel, don't believe necessarily that the luminiferous ether exists, but there's also a lot of Nobel laureate, physicists that say that it does, and it's, there's a big debate on it. Let's just put it that way. But by using that very same gyroscope, whether you believe in the ether or not, we actually devised a way to tell us whether or not it was in fact Earth rotating. Okay. And it was really pretty simple, right? So, first of all, do you understand at all how the fiber optic gyro works, how laser interferometry works?
well, not really, but I mean, I get the
Okay.
gist of it. I get how a gyroscope works and how the gravitational pull works on it. And then when there are spins, there's different. It marks one spot, and then it calculates the time interval it takes. Then it calculates the angle, how much is the angle is like changed.
Well, that would be for a gyroscope, yes, but a fiber optic gyro works a little bit differently. It works on something that's called the Sagnac effect. And the Sagnac effect is basically, um, it goes under the assumption that if light is traveling through a medium, right? In other words, they speak of light as a wave, right? So you have to ask yourself, well, what is a wave? What is it waving, right? What is it traveling through to cause that wave? What is the medium that light is actually waving, right? Well, scientists have been saying for centuries that it is in fact this luminiferous ether, and that is what I actually wound up claiming that it was that was actually rotating, the luminiferous ether. Now, here's how and why I came to that conclusion. So we went back and we looked at these experiments from over 100 years ago and the assertions about the Sagnac effect and laser interferometry. And it turns out that what they say about the luminiferous ether is that it rotates very much, or it behaves very much like a magnetic toroidal field. Are you familiar with a toroidal field in a magnet?
Yes.
Okay, so the ether very much behaves in the same way. It actually is moving. It's not a stationary thing. It is moving, and believe it or not, it propagates vortexually, right? And it just so happens that that vortex rate is about 15 degrees per hour. Now, again, how is it that we were able to figure that out and that it was not Earth rotation? And the answer is really quite simple. So if I'm taking, and this is, by the way, exactly what we did. So we took the fiber optic gyro and we went to a place in Colorado called Pikes Peak. And Pikes Peak is at 14,125 feet above sea level. Okay. And we did our measurements there and we got essentially our equivalent to the 15 degrees per hour rotation rate from Pikes Peak. Now, again, whatever you want to call it, you can call it the ether or you can call it Earth rotation, whatever you want to call it, that's fine. But what we're trying to prove here is that it was not Earth rotation that we were picking up. So we did that measurement at Pikes Peak and we got a value for it. Okay. And then we went down to eastern Colorado following the exact same line of latitude. Right. And why we followed the exact same line of latitude, I'm going to tell you here in just a second. But we went directly east in Colorado on the exact same line of latitude down to just over 4,000 feet. And then we did another measurement. Okay. So would you agree that if I am measuring something that rotates or that measures spin, right, or a rotational rate, that it should not matter whether I take that rotation rate at the bottom of a device or at the top of a device, especially a spinning ball. It would be the same whether you took it right on the globe or an inch above the globe. Would you agree with that?
Yes.
Okay, and you would be absolutely correct. It would not vary at all because it doesn't matter where you would be, high or low, on that same latitude line. It is going to rotate at precisely the same speed. Well, here's the problem with that. What we found was that when we did the measurement with the fiber optic gyro at the 4,000 foot elevation, we had about a 1.3, 1.4 degree per hour variance from that done at the 14,125 foot elevation on Pikes Peak. Okay. So we thought, well, that's pretty interesting because that actually equates to be 26, 27 degrees per day, right? That's a huge number. So we did it again at a different place, Guanella Pass, and again, and again, and again. And we did it in several different places in Colorado. And again, each time we then went to its corresponding latitude line at a lower altitude. And every single time we got a greater than 1 degree variance on the two measurements. Well, why would that be? Well, if you think back to what I just said about how the luminiferous ether was always said to propagate, and this comes from the people that coined the term, Newton, Maxwell, Clerk Maxwell, all these people that talked about this originally, then all you have to do basically is visualize it as a vortex, i.e. like a tornado, okay? So if you are looking at a tornado and you look at it on a z-axis, right, then at the top of the tornado, right, it's rotating fairly slowly. And as you go down that z-axis down towards the ground, it rotates faster and faster and faster, right? So you have a considerably faster rotation rate at the ground that you do, from high up in the air. Would you agree with that?
Yeah.
Did I lose it? Okay,
Yeah.
good.
No.
All right. So that again is exactly what we are saying that the luminiferous behavior is propagating as, right? A vortex. So the problem here for the globe is that when you get a 1.3, 1.4 degree per hour, which equates to 27, 28 degrees per day, something like that, difference in rotation, then that pretty much tells you unequivocally that what we are picking up is not Earth rotation. And it is more commensurate with that vortexual behavior that science has always told us that the luminiferous ether actually behaves in this vortex, right? So we did this multiple times, and every single time, we weren't expecting such a huge variance. But when you're talking 1.3, 1.4 degrees per hour, that's actually huge for 10,000 feet. So we can only imagine that that number grows even greater if we were able to go higher and lower. But the most important thing is what it proved unequivocally is that what we were picking up was not Earth rotation. And do you see the logic behind that as to why we know that it wasn't Earth rotation?
Yeah.
Okay, so that's it. So whether or not anybody wants to accept that it was in fact a luminiferous ether, as I claim, and as other people claim, that's up to you. But the primary goal here is to prove that what it did pick up was not Earth rotation. And in fact, when they did this over 100 years ago in the Michelson-Gale experiment, they had to do another experiment called Airy's failure to try and determine what exactly it was that was spinning. Was it the Earth or was it the sky? And so what they did was they devised a very simple optical experiment called Airy's failure, in which they measured the rotation rate optically with the telescope, and then they filled it, full of water. And theoretically that would slow down the propagation of light through the telescope. And then the idea was is that if they had to tilt the telescope further forward, then the light would not be coming in at the correct angle. However, if they didn't have to tilt the telescope forward, then the light was already coming in at the correct angle of 15 degrees per hour, indicating that it is in fact the stars that are rotating and not the Earth. Well, guess what? Airy's failure, same conclusion. It concluded that it was in fact the star. So now not only do we have the FE cores version of testing whether or not it was Earth rotation, but we also have Airy's failure from back in antiquity. And to this day, you still have people saying, well, we built these gigantic laser interferometers that are stationary and sitting in one place, and of course they are going to be picking up a rotation just like we did. But the problem is there's no way to falsify that if you cannot move that detector up and down on a z-axis to see if whatever it is that you're measuring is changing velocities at different altitudes or different z-axis. Okay, so that is how we know unequivocally that what we were not measuring was Earth rotation. And of course, because the producers of Behind the Curve did not want that information to come out, they skewed it and made it look like, wow, dummy flat earthers, they proved it, with their own equipment, and then sit there and keep denying it. Well, they didn't include the rest of the story, and that's kind of the problem that we have with Behind the Curve. And that's all I have on that, unless you have any questions.
No, I'm just wondering why. I mean, it's just weird why they wouldn't include it.
I'm sorry, it's weird why they wouldn't what?
Include it, because like lots of people, I don't think you've told this to many people.
I have told this countless times. It doesn't get any press. And I told it to them, and I'll tell you why. And the producer even said it himself. They were all for giving Behind the Curve a fair representation until they went to the 2017 Flat Earth International Conference in Raleigh, North Carolina.